Welcome to the Lattice Developers Conference. My name is Ricardo Shiroma. Today's session is about high quality video and conference solutions. I have a guest today, Bertrand Renault from Waves, right? Will be presenting about how FPGAs, AI can help video conference solutions, right? From the computer vision, image quality, and also the audio solutions. Just before I start, I want to introduce myself. I'm Ricardo Shiroma. I've been with Lattice for about 3 years. Before joining Lattice, I spent about 20 years between Dell and HP, where I led several product development teams, right? And uh, I joined Lattice to help Lattice grow in this client compute video environment. and I'll let Bertrand introduce himself. Go ahead, Bertrand.
Thank you, Ricardo, and the Lattice team for giving Waves the opportunity to present today. So my name is Bertrand Renaud. I'm Senior Director of Strategic Partnerships for Waves Audio. Waves Audio is the leader developing advanced audio software for many applications. And so in this presentation, we'll show you how Waves and Lattice do collaborate to create new use cases, combining vision and audio solutions.
All right, thank you, Bertrand, for joining us. Right, I think we have a good agenda that we want to share with you. We start with defining the role of a video conference. I think that is we are here in a webcast, so I think most of us know exactly the problems that we face, right? And but we'll just highlight some of the problems and how we can use AI and FPGAs to enhance the video quality. And then Bertrand is going to talk about how Waves work on the audio solutions to improve the quality, and then we talk a little bit about the future of video conference devices. So with that agenda set, let me start. And I want to just highlight how crucial video conference is today, right? We live in an interconnected world where it's just not nice to have a video conference, right? The hybrid work environment is here, right? Everybody or most of people working companies that spans across multiple time zones. And with the pandemic in 2019, we saw how impactful it was and how people have to move it to using more video conference solutions, right? And but video conference being a gateway for communication, collaboration, and even connecting us with our family members for those who not live close by the family, right? It also helps a lot in the uh, in the interactions, in collaborating in creating innovative solutions, right? That it allows us to share ideas, make decisions, right, in real time, even when we are not apart, right, in a more interactive way, right, that helps you to read people's expressions, right, understand what is going on. It's just not the phone alone is not useful anymore, right? We really need to be present in our video conferences, right? And that's drive a very important experience because if you are counting on video, we don't want to be pixelated, right? You don't want to have a video that has garbled audio, right? That hinders your effective communication. The quality of the video and also immersive audio is not more enhancement. They are foundation for productive meetings nowadays, right? When 83% of the people who use this video conference spends like 8-10 hours or more per week doing video conference, right? See the facial expression and every presentation is like here clearly audio is imperative, right? We need that in every single conference room and also for people who are working remotely using their laptops, right? And that is also an important relationship where the video conference is not just associated more with all those benefits into multiple sites, but is the office to home, right? And it helps to reduce uh, expenses, travel time. It helps to improve the better life, work and better life, right? So this is all important, right? And according to some global markets insights, they believe that the industry is going to be over $20 billion in 24, and you continue to grow, right? As we see how computer vision, uh, audio solutions, and FPGAs can enhance and revolutionize the video experience, right? There's also issues on what the users are experiencing, and that's what I'm going to talk a little bit, right? As in this slide, we can see some of the common issues that we all experience when we are using video conference, right? Or even if we are not experiencing, some of the folks in the other side might experience that, right? And there is still a lot of benefits, like and challenges. And there is West Communication research that shows that about 54% of the full-time employees in the US that participate in video conference have to stop video conference because they couldn't figure out the issues, right? And some of the key issues might be problems with the technology, right? There is more and more technology coming to the video conference room nowadays, right? It's not just the phone, right? That is in the room now. We need to have the phone, the screen, the cameras, right? There are multiple components there that makes the technology integration more complicated, right? There is the lack of modern audio conference devices, right? Sometimes you have the old phone in the room that it doesn't have like good speakers or good microphones, right? So you have bad audio on the other side, right? Sometimes people are in a noise environment, right? And you need to have very good noise reduction uh, technology to help the people in the other end to understand what you're saying, right? And there are other technical glitches with internet, right? That sometimes you don't have enough bandwidth. So what can you do, right? How can you keep this good quality video and the presentation going, right? Issues sharing screens, right? It becomes complicated. You have multiple windows. You don't know which window you're sharing. Sometimes you go and share one window is not the window that you want, and you might be sharing private information as well when you don't know, want to do that. And the video quality, as I mentioned, is very important, right? So a lot of times you don't have the bandwidth to share a good quality image, right? Or sometimes you cannot share the image. So how can you express yourself? Those are all challenges that we can make those interactions in a meeting room or in a video conference very challenge, right? And we hope that with Lattice FPGAs, right? And with the Glance software and all the capabilities that Lattice had now with Glance, which came from acquisition that Lattice did about AI capabilities, especially focus on detecting the computer vision and the users. That is something that we believe that is going to be really imperative. And also, we have partners such as Waves, and Bertrand is going to talk more about that as well, that help us with the audio solutions as well, right? So we have video conference solutions that we just talk about that can be user related or network related, video and audio related, and all those issues affect the experiences. And to solve those issues, we need technology that can provide low power, uh, optimize performance, and most importantly, deliver an end-to-end solution. And that's where Lattice FPGA and Glance and Waves can partner to really deliver the end-to-end solution, right? With the low power FPGAs that deliver really high performance, sensor agnostic, and adaptable that we can support any sensor. Work with multiple APIs. Uh, and that is really important as we talk about video conference solutions, right? Because it can go from a laptop, a webcam, or to the entire room-to-room solution, right? And for all those different sensors, the FPGA can be use it, right? And as we combine that with the capabilities that Glance brings to the table with the computer vision, they help us to understand the context, right? Not just how many users are there, what the users are doing, what is in the background, right? We can detect objects, right? We can detect gestures. There's so many opportunities where computer vision can enhance the video conference, and combining those two, right? We really want to deliver the lowest power solution, right? The best performance, as we have multiple FPGAs that can adapt from the smaller webcam to the large video conference solutions, right? With enough computer power to help process the image, the computer vision AI, and also support the experiences in audio, right? And delivering that as a package, or most of the components on the package is where the partnership between Lattice and Waves can really show the right path for the OEMs that are building solutions for video conferencing. Uh, as we talk a little bit more about those type of solutions, right? I think the first one that I'm highlighting here is really AI noise suppression and voice clarity. There are more AI audio things that we can do in partnership with Waves, and Bertrand is going to go a little bit deeper into this topic when he presents his session and introduce Waves to all of you. But when you look into the video enhancements, right? That is an area that Lattice has always shined, right? With a lot of IP in video quality, right? And we can really help to work with any sensor, right? Deliver the best ISPs, the best image quality, but also supplement that with AI, right? With bringing super resolution, upscale video streams, right? Driven AI color correction, light correction, and all those implementations can be programmed into the FPGA. And these enhancements are going to be real time and at a very, very low power consumption, right? Those are equivalent when you're using solutions as in the PCs, right? You need to be using a lot of the SoC power, and we can bring a lot of the pipeline to the FPGA. And as we talk about image quality and understanding, like we create this great image, and now we have issues streaming that image, right? So how can we use FPGAs for adaptive streaming, right? That is can adjust the quality of the video stream based on the bandwidth and resources, right? And we can work and depend on the type of solutions you have on both ends, right? Where you are reducing the quality as we stream, but you are upscaling back the quality on the other side, right? That is really focused on creating the best video experience, right? Depending independent of the network condition, right? So those are really use cases where you can see on platforms like the video streaming platforms are using those type of technologies as they are owning the end-to-end, right? So that is a similar type of applications to be using in video conferencing solutions. And we can do more, right? As we talk not just about improving the image quality, but understanding the context, right? So understand where the user is and what is happening in the background is also an important thing, right? Because the settings that I need on my private room here, where there is no noise, might be very different than if I'm in an open environment, right? And just on the picture that I'm using there, like I'm blurring my screen right now on my background right now, but what if my kid just come in, right? And I don't want to then to be distracting the conference, right? I could auto blur in these situations, right? Or if I am in a coffee shop, like I can make sure that my noise reduction or my is really up to the task, right? So all those scene detections are becoming more and more important in the video conference devices nowadays, right? And how do we implement the FPGAs, right? So in video conference, it can be as part of the computing the video streams, right? Where you can have multiple cameras coming to the FPGA, right? We consolidate those multiple camera feeds, right, and send to the host SoC, which can be a laptop or it can be a video conference device, right? We can do the real-time video encoding of all those cameras, right? As we are doing that video encoding to reduce the bandwidth, we can also working at the quality of the video and the audio, right? By as we are monitoring on the cameras, understand the lighting conditions, right? Understand the color temperature, right? Understand the noise level in the room, and more advanced solutions that Bertrand is going to talk as he talks about waves in the audio processing, right? As we can do all those capabilities. So that is how we do really incorporate FPGA and computer vision, all the image quality and audio enhancements in a video conference device, right? So as every application or every system is going to be unique, right? We can provide more details on how we do that based on your project as well. Okay, so now I'll hand it to Bertrand. He's going to talk about waves, right? So Bertrand, please go ahead.
Thank you, Ricardo. So before we get into how hybrid solutions between vision and audio works and our collaboration, I will introduce Waves, our company, so which exactly started 30 years ago, where Gilad Keren and Meir Shashua revolutionized the music industry in creating the first audio plugin, which was named the Q10, and it was the starting point of introducing audio processing to big music studios. So it's our DNA. The music industry and music studios is the DNA of Waves. And so as respective CEO and CTO, Waves, Gilad and Meir have grown Waves to become one of the most recognized audio leader, provided hundreds of plugins to music, movie studios, broadcasting and newsrooms, providing tools for live concerts, and delivering those advanced algorithms to consumer products. So consumer products like laptops, Chromebooks, smartphones, TVs, smart speakers, headsets, and so on. So making us today to ship over 100 million units annually with Waves technology inside. So as a major recognition of our peers and the industry, we received in 2011 a Technical Grammy Award. And this year, in 2023, we received an Emmy Award for our breakthrough Clarity VX, which is an AI-based noise and reverb suppression. So if you can get to the next slide, Ricardo. So if you take a consumer device like a laptop today, which has many use cases for audio and vision, is a very complete device. We have pretty much advanced solutions to address all the use cases, all those use cases and content that a user might have. For audio render, our suite is named Max Audio. It's a powerful studio quality suite of algorithms that transform the sound of speakers, and not only speakers, can transform the sound of audio accessories that you connect to your device. For voice capture, so the microphone side of things, we have Max Voice, which is a suite of algorithms built to optimize microphones for clear conferencing and speech recognition as well. So human to human and human to machine interactions. And finally, our 3D audio technology, which is named NX, can expand the sound of speakers all around you at 360 degrees, and was the first to introduce head tracking to the market, but we'll get to that in the next few slides. So bottom line, with Waves, you can have a Teams call, laptops on your knees, being on a noisy place, and using any kind of audio accessories, that was my meaning, by the complexity of audio use cases that you can have in real life and you can manage with audio processing. If you can get to the next slide. So on this slide, I will focus more on audio render and explain to you what makes the sound of a poor speaker system becoming good enough and the sound of good speakers becoming excellent. So you need to understand that our solution actually consists in two aspects. The first one is the audio software, the audio algorithms, the suite that I just mentioned and talked about, which are processed on a CPU, could be processed on an audio DSP, nowadays also on NPUs, neural processing units, but also on FPGAs, like Lattice. And then the second phase is the acoustic tuning aspect, which is very specific to the acoustic characteristic of the device itself, where the speakers are placed, what type of speakers, the back volume, all those kind of things, microphone placements, microphone arrays, all those discussions are device specifics. So we need to tune each of the devices to that specific characteristics. And we are very proud at Waves in listening and tuning every device that we're working with our global team of acoustic tuners and complex audio labs. So the first one is the audio compensation or hardware compensation, I will say, which will compensate for all the acoustic weaknesses of the device. Things like equalization, keyboard rattling, if you have an asymmetrical design between the left and right audios, distortion, and things like this. In the second phase, we provide audio enhancements on the entire bandwidth and spectrum, bass, treble, voice, stereo separation. We're going to push the volume even further. And we're going to validate this on multiple contents, multiple use cases, so music, movies, gaming content, and etc. And the third one is to deliver the immersive experience, the 360 3D experience that I was mentioning, using our NX 3D audio algorithm, which will take advantage of the speaker placement and validate the effects with certain movies and the latest video games. So if you can get to the next slide. On the capture side, so again, the microphone sides, this is probably the one that I've seen the most revolution in the past few years with going from a multi-microphone beamforming kind of technique. If you remember the Amazon Echo 7 microphones on the top, the beamforming technique, to something that is AI-based solution. And that's valid for all our latest features and solutions. So the way it operates, that's very simple. We collect relevant audio data in the field, noise distractors, and so on, to train a model. This model is meant to evolve over time. As we find new use cases, new distractors, new corner cases that we learn with, our customers and consumers. And then this model will feed real-time a machine learning algorithm, which provide ultimately the desired feature. So since 2020, Waves has released many AI solutions to the market, and each of them have their own model, which has evolved over time. So one example is the Clarity VX, which I mentioned before, which just won the Emmy Award. This technology uses AI to completely remove noise and reverb, and this while preserving the voice integrity, which is obviously very critical for conference call systems. You can get to the next slide. So now let's talk about how Waves and Lattice do collaborate and can bring more advanced use cases to consumer products using audio and vision. This first use case and example is our dynamic volume control. We use Lattice proximity metadata here to detect if the user is stepping away from the laptop. And we use this information to boost the volume automatically. So in other words, you can compare this feature to what you have today in a car, in a vehicle, where the volume is adjusted to the speed of the vehicle. Here it's the same principle where we adjust the volume to the distance of the user. So with the AI vision algorithm of Lattice, we detect the distance and we boost the volume accordingly. To get to the next slide. The second example is far more complex. It leverages the Lattice head tracking technology to detect the head movement and adjust real-time our 3D audio algorithms to always keep the display audio at the center. So meaning like if I'm a user and I turn my head right, the audio center will remain on my left here. And if I turn on the other side, it will remain here. So you will have more immersive experience in the sense that it will reproduce in what you observe and what you experience in real life. If you turn your head, the sound source is not moving with your head, right? The sound source is actually staying at the same location. So this is what we are able to reproduce with the Lattice algorithm and our head tracking technology. In a movie, for example, it duplicates your experience. As the immersive scene is always adjusted to your head movement. And it doesn't have to be big movement. It can be micro movements and it's always adjusted. So you always feel that the scene stay where it's supposed to be on the display. It's the same in a video game. It provides the gamers with extra cues of the gunshots and footsteps in the game. And usually in those games, you can hear before you see. So that gives you the advantage. And for the topic of today, which is conference call systems, if you are able not to have a flat sound, but to have an immersive sound where you can have multiple participants placed around the table, Ricardo on my left and other people on my right, and you have this immersive experience. And when you turn your head, Ricardo is actually coming, his voice is coming face to me. This is where you provide the most realistic experience to conference call systems. And actually being on those meetings and conference calls for many of us, 8 hours a day or more, we believe it's going to reduce fatigue as it creates more the real life experience. We produce more the real life experience. All right, thank you, Ricardo.
All right, thank you, Bertrand. And we'll have the Q&A in the end. So just keep around so we can ask the questions. And let's go and talk also a little bit about how video conference and AI, right? Why it is improving. So we just talk about a lot of examples, and just to summarize, right? Understanding the voice, understanding the audio position is really important, right? But there are more things that are existing today, right, or being implemented about voice recognition, be able to transcribe the voice, right? That is all technologies or our experiences that can be improved with the algorithms that we just talked about, improving clarity and noise reduction, right? Because imagine if you are doing a transcription of a video conference and the person on the other side is on a on a coffee shop and there is very loud, right? And you don't want the the transcription to have the noise or words that are people be captured on the microphone from the back, right? So all those technologies that we just mentioned are foundation technologies to bring the next level of experiences into the environments, right? Understanding uh, people like and who they are, right? Being able to auto frame in the meetings, right? So that is also things that you can do. The combination of the computer vision and audio, as I think Bertrand was just describing, right? When you have multiple people in the room, understanding where the sound is coming from and emulating that in a real life experiences, right? And also for inclusionist translations, right? Things that are happening in today's world that is all supported by those technologies or those foundation technologies that we just talk about. And I want to just transition to a little bit more about where we see the market going, right? Because this is a developers conference, right? And we're not talking just about things that are in the market today that have already been developed, but we should be thinking about how to use those foundational technologies to create the next generation, right? The future of the video conference. And I bucket those in really four four buckets where we are seeing a lot of technologies emerging in these areas, right? The first one is inclusiveness, right? Because this is all about the user, how they are using the experience, right? We talked in the beginning how video quality, audio is important for make the person to participate in the meeting. So that is where inclusion has come about, right? That's where all those technologies come that you can use AI to understand the voice, understand that like drive the summaries, drive the speech, right? But it's also for assistance, right? And you could be using that to understand the cultural differences, right? As those larger language models become more prevalent, like you can customize those to really help in the work environment, right? And the industry that you are in. Uh, the collaboration aspect is not just we talking in video, right? As we are using on a video phone just doing the presentation. We need to be more effective, right? When we are face to face, we can go to the whiteboard, right, and write in the whiteboard and be collaborative on those, right? Those new experiences or those experiences that you have on the face to face, they also need to come to the video conference devices, right? We should be using whiteboard and understand where you are there, right? Whether it's physical, like go focus on that whiteboard, understand and the text that you are writing there is how does it goes into the meeting, right? Doesn't matter if you're using a real whiteboard or virtual whiteboard, right? We should be able to understand the context about what is happening there and adaptive the solution to be focused on the content that is being discussed, right? So that is what multimodal collaboration is, and it's going to be really empowered by a lot of AI, right? And as we thinking about going to meetings, sometimes it's so hard to remember what happened, right? And or to take the notes during the meeting when you are presenting is very hard as well, right? So smart summaries as these large language models come to market and understanding what is happening, right, becomes really important to document and also to drive the actions, right? You no longer need to be really typing or like understand what is happening during the meeting. Like the AI should be able to hear what was discussed and be able to summarize that, right? And not just that, but understand the actions that should be driven out of the meeting and be able to assign those for the meeting participants, right, as well. And as I mentioned about even going a little bit more along the way, right? There's VR and AR is still emerging technologies, but we see a lot of new AR, VR devices coming to market that are really focused on bringing this multimodal interaction to most of the users, right? And those visual or virtual collaboration spaces are going to become more and more important, right? As it can be used just for the collaboration, but also for training, for simulation, right? And really get the engagement of the audience as you are in person there, right? That's kind of like where the future of video conference is going to come, right? Where it doesn't matter whether you're in the office, in your home, right, or in the other side of the world, right? When you are collaborating, it should be as you are face to face, right? As and it should be as transparent to the end user as possible. Okay, so I'll thank you everybody for staying with us during this presentation. I'll now move it to the Q&A session. So if you haven't typed your questions, please add your question. And if you don't have time to answer a question, we will follow up via email, right, to be able to provide you the answers. I can see a few questions. I'll start with first question to Bertrand here. So the question is, I'm not familiar with audio processing. Is there audio processing on every consumer device?
That's a good question, Ricardo. The answer, general answer is yes. You can find at least a minimum set of audio processing. I would say on every device, you will need some equalizer, bass enhancement, and volume management will be a minimum set of features that every audio device will have today. And it could be an headset, a speaker, any kind of Bluetooth speaker. We'll have this kind of features. But the trend is to get a lot more today, especially with AI and more immersive audio, which is more and more expected, and are led by the premium solutions, which see as audio as an essential component of their of the feature, as audio is a vehicle for emotions. It improves the experiences, and it also defines your brand identity. Not every customer wants exactly the same audio. It defines a brand. You want to have the audio that defines your brand. So audio processing is key and is happening on every device, every consumer device today. All right. So let me see your questions here. Let me ask you a question, Ricardo. It's for you. Can you provide more details about glance and the advanced detection capabilities?
Oh, yes, of course. So, uh, actually, we have another session about enabling PC experiences that is going to go in more details about how to use the FPGAs and Glance for those computer vision experiences. For those who are not familiar with the Glance or Mirametrix, Lattice acquired Mirametrix in November of 2021, right after partnering with Mirametrix for developing computer vision for user detection. We decided to go and acquire Mirametrix because they have a very, very deep understanding of computer vision. Right, we have in our Montreal Develop Center over, I think now 70 engineers that are really focused in computer vision and can tackle the most challenging AI AI problems in computer vision. Today, the focus is really in understanding the user context, right? So we can understand where the person is, like track landmarks, right? That help us to understand where the person is looking at, right? Go to gaze tracking, where you're looking at, gestures. A lot of experiences can be supported with that, right? So please attend the session about enabling PC, enabling the next generation of PC experiences that we're going in a lot more details about those capabilities. Okay, I have one more question to Bertrand here. Why will you perform audio processing on the device rather than in the cloud?
That's a good question about the architecture and distribution of audio for several reasons. The first one is probably the most obvious is the acoustic characteristics of the device itself are specific to the device. The cloud will not know where the speaker placed, the microphone's placement and everything. So this is one of the most obvious reasons why you do it locally on the device. The second is the trend is to offload more and more processing at the edge of the device itself, not just the CPU. So you will offload to specialized DSP or FPGA, like the Lattice solution, to have lower power consumption, meaning that you could eventually keep the CPU in a low power mode and do the processing and detection locally at the edge, but also to achieve low latency. If you get closer to the sensors, the microphones, and things like this, you can do processing at very low latency. You don't have to interrupt the CPU and try to get some priority for that. And the last, I think, obvious reason is people are more and more concerned about privacy. We heard about microphones listening all the time and eventually having an operating system being hacked to do that. So someone can listening to you. If you do it at the edge on a specialized FPGA, for example, you don't have this complexity of operating system. It's going to be impossible to do this, and you're going to protect the privacy of the owner. Yeah, I see another question for you, Ricardo. What is the role of generative AI in video conferencing?
Yeah, that's a very good question, right? So, um, generative AI or all those new models that are very new. So there is a lot of opportunities for developers to go and explore uh, using generative AI in video conference devices or solutions, right? But if we start with the inception of how those larger language models or generative AI transformers coming to market, right? It was really the inception was to understand language and help with the translation, right? And then, of course, as we more understand the context, it becoming like open areas for other applications, right? As what we see today. The most like relevant today or like easier to think about is really on the smart summaries, right, where you can understand what is happening or what's being talked in the meeting, translate that, summarize it, create the actions, right? This is a very generic use case, but like as you move to the more advanced use cases where now if we start thinking about the AR VR, right? So that's where generative AI can be the assistant behind all those solutions as we try to ideate, right? Create new concepts, right? That can be using with generative AI in real time, right? So you don't need to rely more on like drawing on a whiteboard, right? You can be saying and using a whiteboard that is generated as you are talking and ideating, right? So those are a little bit more advanced experiences, but yes, like generative AI has a lot of opportunities for developers to go and create innovative solutions for video conference for sure. Okay, I think that's it for the Q&A, right? So if you don't have your questions answered, like we will follow up as you enter your questions, right? I really want to appreciate everybody for attending our session. I will just ask Bertrand if he has any last words for all the attendees.
No, I want to thank you all the attendees, to attend this session and and follow up with me and Waves for any questions you may have on audio.
All right. Thank you, everybody. I hope you are enjoying the Lattice Developers Conference, and I hope we can hear more from you. Thank you.
Thank you.